Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 21 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2017, Grid Game. Okay, so let's read the problem statement first. So this problem is actually very interesting and important. Okay, so in this problem you are given a zero indexed 2D array grid of size 2 into n. Okay, 2 is nothing but the number of rows and n is nothing but the number of columns. Okay, where a grid R of C represents the number of points at position R, C on the matrix. Two robots are playing a game on this matrix. Okay, so there are two robots. Both robots initially start at 0 0. Okay, so robots are going to start at this particular index. Okay, so if this is 0 row, first row, 0 column, first column, second column, so both the robots are going to start from this position. Okay, 0 0 and want to reach at 1 n minus 1. Okay, so both the robots wants to reach to this position. Okay, this position. Each robot may only move to the right. Okay, right or down. Okay, so this is the navigation, okay, that two robots are going to follow. At the start of the game, the first robot moves from 0 to 0 to 1 to n minus 1. Okay, so initially first robot is going to start, right, and this robot is going to collect all the points from the cells on its path. For all the cells RC traverse on the path, grid R of C is set to 0. Okay, so if a robot see this red color, okay, if a robot traverse this path, okay, like this, then see all these points are going to become 0. Okay, then the second robot moves from 0 0 to the destination. Okay, from source to destination. Okay, second robot collecting all the points on its path. Note that their paths may intersect with one another. Okay, but there is one condition now for navigation. Okay, the first robot wants to minimize the number of points collected by the second robot. Okay, so first robot is very greedy. Okay, he wants that his opponent only collect minimize number of points. Okay, so in contrast, the second robot wants to maximize the number of points it collects. Okay, second robot is also very greedy. He wants to maximize the number of points he wants to collect, right? But for first robot wants to minimize the number of points collected by the second robot. Okay, so we can say that this first robot is thinking bad of another robot, and this second robot is thinking about its own benefits. Okay, so which robot is good, second robot or first robot? Obviously second robot, right? Because he's thinking about his own benefit. Okay, he's not thinking bad about others. Life lesson, right? Okay, if both robots play optimally, we have to return the number of points collected by the second robot. Okay, so this is what we need to return. Okay, so now see this example. Okay, so grid is given to us 2 5 4 and 1 5 1. Okay, initially. Okay, so now first robot, okay, the optimal path taken by the first robot is shown in the red. Okay, so 0 0 0. Then the optimal path taken by the second robot is shown in the blue. Okay, so because if a robot moves like this, then he is going to collect 4 points. Okay, if he moves like this, then he's only going to collect 1 point, right? So 4 is beneficial for him, right? So second robot will collect 0 plus 0 plus 4 plus 0, 4 points. Okay, all right, so now how we are going to solve this problem? Okay, so see this one example here. Let's pick the same example. Okay, 2 5 4 and 1 5 1. Okay, so let's suppose this is my grid. Okay, we have 2, then we have 5, then we have 4, then we have 1 here, then we have 5 here, then we have 1 here. Okay, so now here this is 0 row, first row, 0 column, first column, second column. Okay, so now initially robot 1 is going to move. Okay, so I'm using red color pencil for robot 1. Okay, robot 1 wants to start from here and he wants to reach to this position. Okay, so now here let's suppose if robot 1 follows this direction. Okay, 2 1 5 1. Okay, if robot 1 follows this direction. Okay, R1 follows this direction. 2 after 2 moves to 1, after 1 moves to 5, and after 5 moves to 1. Okay, and you know robot can only move to the right or down direction. Okay, so now if robot 1 moves to this position, then robot 2, what is the best path for robot 2? Okay, best path for robot 2 is going to be this one, obviously. 2, 5, 4 and 1. Okay, because here 5 and 4 is there. Okay, then the robot 2 is going to collect 9 points. Okay, if he follows this path, because this is going to become 0, this is going to become 0, this is going to become 0, and this is going to become 0. All right, clear? Then the best path for robot 2 is going to be starting from this 0 by 0 set in this 0 points. Okay, then 5, then 4, and then 0. Okay, total 9 points. This is going to be the best path. Okay, so here if a robot follows this path, so here can I do one thing? See here, in this side only we are making a complete column 0. Okay, complete column is 0, where our robot is going to take a turn. Okay, where our robot 1 is going to take a turn in that column is going to be completely 0. Okay, robot 1 turns here. Okay, and this complete column becomes 0. Okay, and then after making a turn, whatever the remaining portion, okay, because robot 1 can only move to the right. Okay, only then we have just 2 rows. Okay, robot 1 then can only move to the right direction. Okay, then after this all the rows are set to 0. Okay, after this, after making the turn, after making the turn, all rows are set to 0. Okay, until the destination. Okay, so this is the remaining portion then. Okay, and definitely my robot 2 also wants to maximize his profit, right? So he's going to collect all these points. Okay, so here can I do one thing? Can I first calculate the complete summation of this complete row, total sum of all the elements in this complete row? So total sum of elements in this complete row is 2 plus 5 plus 4, and that is nothing but 11, right? So this is going to be the first step. Okay, that is nothing but first row sum. Okay, so now what I'm going to do? Okay, I'm going to initialize. Okay, initially second row sum I'm going to take it to 0. Second row sum I'm going to take it 0 initially, and then we have to find the minimum sum, right? Minimum sum. Okay, so here if both robots play optimally, we have to turn the points collected by the second robot. Okay, and definitely this first robot wants to minimize the number of points collected by the second robot. Okay, so minimum best points that this robot 2 can collect. Okay, so here let's create one variable. Okay, minimum sum. Okay, minimum sum, and set it to 0. Okay, so now I'm going to iterate, okay, over all the columns. Okay, and I'm going to check if my robot takes turns at this particular index or not. Okay, at this particular column or not. So initially I am at this particular column. Okay, initially I'm at this particular column. Okay, so here I'm going to run one for loop. Okay, for loop, let's say turn index starting from 0, and turn index is less than number of columns. Okay, columns length, and turn index plus plus. Okay, so initially let's suppose here if my robot takes turn. Okay, here at 0 index if my robot takes turn. Okay, at this particular, then total first row sum is 11. Okay, now see carefully, first row sum is 11. Okay, now from this first row sum which is 11, I have to subtract these two. Okay, because robot is going to take the turn from here. Okay, so this grid 0 and turn index 0. Okay, grid 0 0 I'm going to subtract if my robot takes turn, robot 1 takes turn. Okay, I'm talking about robot 1 here. So if my robot 1 takes turn at 0 column, so here I have to subtract 2. 11 minus 2, 11 minus 2 is nothing but 9. Okay, all right, this is done. 9. Now minimum row sum. Now minimum row sum. Okay, minimum sum. Okay, this variable minimum sum. So here I have to write this formula, math dot min. Okay, and here what is my previous minimum sum? Okay, I have to compare this with, here I have to write math dot max. Math dot max simply means here I'm trying to find the best path for my robot 2. Okay, so here first row sum I have to pass, first row sum, and here second row sum. So here initially I told you that I keep my second row sum 0, and that is true now. second row sum is 0 because here I'm taking the first turn, right? So if I'm taking the first turn here, this is already set to 0, right? And here I'm taking the turn. Okay, so math.min sum. Okay, so this minimum sum, let's suppose this is initially instead of 0, let's take it to infinity. Okay, very max value. Okay, this minimum sum. So here we have to find minimum sum, which is nothing but infinity. Okay, infinity, and here math.max FRS, which is nothing but 9, first row sum, and second row sum is 0 initially. So here max among them, which is max 9. Okay, 9 and infinity, which is minimum 9. Okay, so minimum sum is 9 here. Until now minimum sum is 9. And now once we calculate this, okay, if my robot 1 follows this path, and we know that then robot 2 is going to collect total 9 points. Okay, then what you need to do, then update the second row sum and add this value here. Okay, because next time I want to make a turn here. Okay, so I have to keep add this. Okay, previous one. So second row sum is equal to second row sum initially 0 plus grid of 1 and 0. Okay, so here 1. So second row sum is going to become 1. Okay, this value. And my first row sum is already what you calculate, first row sum is here 9. Okay, and now minimum sum is nothing but 9 here. Okay, so now let's make a turn here. Okay, if we make turn here, okay, so if we make a turn here, then I have to subtract this 5, right? From what? From my FRS. Okay, first row sum. So I have to subtract 5. So now if you see here, my first row sum is 9. Okay, so 9 minus 5, if I do, I will get 4. And this 4 is correct. This 4 is correct for the remaining portion. Okay, right? If my robot takes turn like this, so here only 4 left, right? So this is beneficial for me, right? This approach. Okay, prefix sum approach. So here 4. Now this is my first row sum. Now calculate this min sum. Min sum is math.min, previous min sum, which is nothing but 9. Okay, from last time it is 9. So here I'm going to write 9, and here math.max of first row sum, which is nothing but 4. Okay, and here second row sum. So what is my second row sum? It is nothing but second row sum 1. Okay, so here math.max 4 and 1, which is max 4. Okay, and 4 and 9, which is minimum. Okay, so from here 4 is coming, and 4 and 9, which is minimum. 4 is minimum, so my this max sum is going to update to 4 now. Okay, 4. So this is correct now. This is correct. Okay, 4. So if we follow this path, then see this 4 left. Okay, this 4 is the best solution for my minimum sum. Okay, so we are going to get the correct result. Okay, second row sum. Now update. Okay, now after that I want to make a turn here. So here we have to add 5. So 5 plus 1, 6. So here this is going to 6. Okay, so now we get the result here, right? Minimum sum is 4. Okay, but let's suppose if my robot takes turn here, then what will happen? Okay, at this position. So if my robot takes turn here, then this complete is going to become 0 na? 2 5 4. Okay, so 4 I have to subtract from first row sum. So here from here, see this blue color. Okay, blue color one now. So 4 was the last one. Okay, so 4 minus 4, it is going to become 0. Okay, done. First row sum is going to become 0. Now minimum sum I have to calculate. Okay, so previous time what is my minimum sum? 4. Okay, this is done. And here math.max first row sum is now 0. Okay, 0. And my second row sum previously, so here 1 plus 5 6. Okay, so here 6 now. So here I have to add 6. Okay, so what is max among 0 and 6? 6 is max. So from here 6 is coming, and from here 4 is coming. So they see it's still 4, and that is correct. Okay, minimum sum is still remaining 4 only. Okay, so it's 4. And now second row sum I have to update. So here add this one. So 1 plus 5, 1 plus 1, 6. Okay, second row sum is 1 plus 5 plus 1, that is 7. Okay, so it is going to become 7. Okay, so in the end my loop ends. Okay, I have checked all the turns. Okay, wherever I'm taking turn, so this ends now. So what is the last minimum sum? it is nothing but 4, and that is going to be my output. Okay, so I hope that you guys are clear with this approach. Okay, so now let's write the code. So it's very interesting, right? And code is also very simple for this one. Okay, so here first we have to calculate the sum of all the elements for the first row. Okay, so here long first row sum is equal to 0, and then run one loop for int num in my first row. Okay, grid of 0 exact. Okay, that simply means that this is my first row. Okay, and inside this first row sum is equal to first row sum plus num. Okay, now after that take second row sum and set it to 0. Okay, because initially I'm going to take a turn at first index itself. Okay, 0 index itself. Second row sum, set it to 0, and then take long minimum sum. Okay, and here just define a max value of long. Okay, long dot max underscore value. Now we have to check all the columns where I can take a turn. Okay, int turn index is equal to 0, turn index is less than grid 0 dot length, and here turn index plus plus. Okay, normal for loop. And here now if I take a turn at first column itself, then I have to subtract. Okay, first row sum is equal to first row sum minus grid of 0, and here I have to pass turn index. Okay, then we have to find the minimum maximum value out of first row sum and second row sum. So here minimum sum is equal to math dot min. Okay, this is what we are searching. Okay, from my minimum sum. Okay, and here we have to take the max value because robot 2 wants max. Okay, so math dot max of remaining first row sum and my second row sum. Okay, done. Then after that, here now in the next step I want to take a turn in the next index, next column. Okay, so here just add second row sum as second row sum plus grid of 1, and here you have to write turn index. Okay, this is done, and in the end you have to just simply return the minimum sum, and that's it. Okay, minimum sum. All right, let's keep it small now. I am keeping small everywhere else. Okay, now let's run it. So now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be O of n, and O of n is nothing but the number of columns that we have. Okay, we are running one for loop. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.